Hello guys, this is Naeem. This is Naeem from Peshawar, Pakistan. Most of the time I'm not showing myself in the videos. Some of the people abroad, they were saying that I must show myself who I am. So I'm working on this alternator. Let me show you something. In the previous video I have also shown you a coil. This coil, it has 275 turns, and with a constant RPM of about 600 to 800, it's giving me with 6 magnets on the rotor. It's giving me 2 volts and about 1 amp, approximately 1 amp, 1.2, but at safer end I would say 1 amp. Okay, with 2 volts and 1 amp, I have done some calculations. There's a formula. I don't know if you will be able to see it on the camera on the screen. One coil voltage is equal to 2 volts. In each phase I have 4 coils. If in each phase I have 4 coils, then 2 multiplied by 4, that gives us 8 volts. So 8 volts is per phase. When I'm intending to make it in a star configuration, so in case of star, 1.732 multiplied by this 8 volt per phase, that is going to give me 13.854 open AC voltage, right? There is going to be a little bit of drop of about 1 or 1.5 or maybe 2 volts due to the rectification. The diodes they tend to decrease the volts. So it will be approximately 12.5 or something like that. What I have in mind is that I will be using these many coils. Let me show you this way. It will be a lot clearer this way. What I've done is I'm going to put 4 coils in one phase, coil A, B, C and D. This is the first phase, this is the second phase, this is the third phase. Forget about the outer coils. This is another configuration I was thinking about. What I've done is this. So 1A is going to be here, 1B here, and 1C somewhere here, 1C here. So I was intending to make it that way, but then I changed the plan and I decided to have 4 coils. So that's why I did this 1A, then 1A, 1B, then this is 1C, and this is 1D, right? So 1, 2, 3, 4. The same goes for 2A, 2B, 2C and 2D. I hope you're seeing this, 2D. Then this is 3A, this is 3B, this is 3B, 3C, right? And 3, no, this is, where did I, 3D, sorry, 3A, this is 3B, this will be 3C, and this is 3D, right? So it is this way. These are about 12 coils and 4 coil per phase, right? Now let me show you. There are people who are not able to configure and see and divide the equal distribution of the coil in a circular path. So I will tell you a very easy formula. Read my words, okay? It's very easy. When we have an angle, this is, suppose this is a 40 degrees angle, this straight from this point to this point and this point to this point, these 2 arms, we are having 180 degrees. At both sides, if we count 180, we plus 180 over here and 180 over here. We have an angle of 180 over here, 180 angle we have it here, right? So we plus this 360. What we do to obtain equal division of a circular a sphere, we divide it 360, we divide 360 by 12. So each angle is going to be 30 degrees. What I did was I made one straight line, put a dot in the middle, and then I using the a tool which is in the form of a D, which can tell you the angle. So this is 30 degrees, this is 30 degrees, each and every angle is of 30 degrees. This is the way I have divided it into equal 12 divisions. I have divided this circle into 12 equal divisions. This is a very much homemade coil winder. I did it myself. I had some piece of wood laying there and some, you know, some metal and some screws and things, and there is a internal mirror coil. So what I do is I wind a coil, I put it into a drill, but as I want, drill is a very high RPM machine, so what I do is I do not switch the drill on, but instead I put this piece of screw into the drill and fix it, and then I rotate it by the hand like this, and I count the number of turns in a coil. This is the way I can turn the coil. Okay, let's get back to my business. What I intend to make is an alternator which could give me a voltage of 24 volts. In order to have a 24 volt, I must have per phase, I must have about 16 volts instead of 8. I have to double this thing. So either it is going to be 5 coils and 3 volts or something like that. I have to increase the number of this, so I want to make it a star configuration. To multiply 1.732, I must have to have at least 24 volt. 24 or 25 or 26. 27 would be a lot better, right? Because after the rectification, the voltages are going to go down. So guys, wish me luck. I don't know, I'm going to make a test coil. Oh yes, there's one more thing I must mention. I have wound this coil. This is a 24 SWG gauge wire, right? I wound it and I'm coming up with 2 volts, right? In order to make the coil smaller, will make it a lot efficient to keep it within the range of magnetic flux. You better, most of the people, they don't know about it, and especially the beginners, so it's for the beginners, that whenever you make a coil, try to make it as smaller as possible, because I'm not talking about the internal diameter, I'm talking about the overall size of the coil. It must not exceed the limit of magnetic flux. How much it goes out of the magnetic flux, that much it is going to be inefficient, right? So what I did was I got a thinner wire. This is 24. No, sorry, this is 22 number SWG. I just went to the market and I bought 22 number. The smaller the greater the number, the smaller the size. I bought 24. Sorry, a mistake. I bought a 24 SWG wire. This is 22. So I'm hoping to get about 300, approximately 300 turns, and I'm sure that I'll be raised from 2 volt to 3 volts at least. So let us test and see what happens. Wish me luck, good guys. Wish me good luck, guys. Have a nice time. Thank you very much for watching my video.